Welcome back, Calculus Scholars. Mr. Benzel here, ready to teach you today about the tried and true way of finding the area under the curve, the integral. And the integral is commonly known as the antiderivative. So our most pretty way to take an integral is when we have a setup of the power rule, which is the exact reverse of the power rule of a derivative. So if I have the integral of something like a coefficient x to some exponent that we'll call n, what we want to do is we want to add 1 to the exponent. And then what we want to do is we want to take the coefficient and divide by the new exponent. Not the old exponent, the new exponent. So I will put divide coefficient. And last but not least, it's as easy as pushing the plus C button, but we always want to end with a plus C. And this is because antiderivatives are really asking, here's something that's a derivative, what is the original function? And we can add any constant that we want, and when we take the derivative of a constant, that is always going to be 0. So let's look at a few example problems here. So your typical antiderivative exercises are going to range from having, nice pretty power rules all the way up to maybe some things that you have to use properties of exponents on. So let's look at a basic antiderivative first, like number 1. So on this one, I like to kind of do one term at a time. So I add 1 to the exponent, and if you're doing this the first few times, you take that coefficient, you divide by the new exponent. Now, if you're really good at antiderivatives, you don't have to do this step, but if you're just, figuring out the coefficient the first time and not want to do so much mental math, then, this is, I think, really good to do. Another thing that's kind of useful is that when you have a constant, if you just add an x, we're good. That is the, so like if we take the derivative of negative 3x, we get negative 3. And then, of course, add a plus c. But make sure that the answer is nice and simplified. So we write this as x squared minus 3x plus c. And always make sure that you are including the plus c. I actually want to go to number 3 first, because we may think that this is a big, bad, rational expression, and that maybe we have to, go wild and think about some type of reverse quotient rule. But if you have a good knowledge of properties of exponents, we can call 2 over 4 1/2. And we will call the x cubed in the denominator x to the negative 3. Now remember, if you're just, kind of simplifying and rewriting the integral, you have not taken the integral. So you need to be keeping that integral symbol in until you have successfully taken the antiderivative. So we do the same type of procedure here. We're going to add 1 to the exponent. Now remember, adding 1 to a negative number is going to get you less negative, so we have negative 2. And we could say negative 2 times what gets us to 1/2. Well, negative 2 times a quarter would get us to negative 1/2. So we want this to be a positive 1/2 when we kind of go in reverse. And on tests, I mean, if you just wrote this, that would be fine. But pay attention to instructions sometimes that maybe they want your answer to be free of negative exponents. But for now, we will just accept this answer as is. Number 2, we're going to learn something next week called a U substitution, to which, especially if we have a really big exponent, there'll be a very nice, useful thing that we can do with U substitution. But I think it is pretty reasonable, since this exponent is small, that you could actually do some polynomial multiplication. So I would just suggest, doing a box method or a distribution. Let's see, 3x times 3x is 9x squared. Plus 6x plus another 6x, which is 12x, plus 4. Always make sure that you are including the dx. And then now we can kind of take this antiderivative. So we get x to the cubed. 3 times 3 is 9. 6 times 2 is 12. So we could kind of reverse engineer this a little bit. Plus 4x plus c. And that kind of ran out of space a little bit. Number 4 is another nice one to work out, because that also looks kind of ugly and rational too, but it isn't if you know your properties of exponents. So I'm just going to erase here to make a little bit of space. Just like the board at school. All right. There's C, remaining C. All right. So anyways, I got my x squared over x to the 5th. So I'm just going to kind of showcase the property of exponents individually. So we have a common denominator, minus 4x over x to the 5th, plus 3 over x to the 5th. And remember, when you have this type of scenario, you are going to write this where you are going to be subtracting your exponents. So I'm going to write this kind of in that nice power rule friendly type of fashion. So x squared over x to the 5th is 2 minus 5 for the exponent. That's x to the negative 3rd. Minus 4 x to the negative 4 plus 3. Remember, 3 is in the numerator, and then in the denominator is at x to the 5th. So we take it out of the denominator and we call it 3x to the negative 5th. And this is because when we do that, like if I had 3 times x to the negative 5th, that's the same thing as saying 3 times 1 over x to the 5th, which is 3 over x to the 5th. Sometimes I get students that make algebra mistakes of this nature, and this kind of affects them and keeps them at the 3 out of 4 level. So just make sure that you're kind of good with these properties of exponents. And then we go and we take our antiderivative. So add 1 to the exponent. Let's see. My coefficient was 1, which is half of 2. But let's see, negative 2 times a negative half. Then we have a minus 4. X to the negative third. And because we have a negative 3 in the denominator and a negative 4 in the numerator, we're just going to call this term positive. And then we're just going to add 1 to that exponent, x to the negative 4. And this kind of has the opposite problem, where we have a 3 over negative 4. So that's going to make it negative 3/4. We'll look at one more. Let's look at, oh, don't forget, add the plus c. That's sometimes what really good students even forget sometimes. Let's look at one more. Let's look at number 6. So, number 6, a little bit of properties of exponents from Algebra 2 can really help us make this problem a lot easier. So I got x to the third, and there should be a dx on this problem, and a x to the 1/2. So let's see, we have a whole number and then we have a mixed number. So what we may want to consider doing with this is kind of write 3 as something over 2. So 6 over 2 is equal to 3. We'll call this x to the 6/2 times x to the half dx. And we use our property of exponents where we add the exponents. So this is x to the 7/2. And my suggestion is, if you're kind of a little bit shaky with a fractional exponent like this, taking the antiderivative, you can always do 7/2, and when you're adding 1, that's like multiplying by, or adding by 2 over 2. So this would get us to a total of 9/2. I'm just going to erase that and call that 9/2. And if you want that coefficient to be 1, a real simple trick that I like is just multiplying by the reciprocal. So the reciprocal of 9/2 is 2/9. And we are almost done. Save for a plus c. So if you can do those properties of exponents, then that's showing me that you really know the nuances of some of those trickier problems that aren't explicitly set up to do power rule. So your goal is to kind of use those Algebra 2 properties of exponents so that you can, whenever possible, create that power rule integral. Thank you very much for listening. We will have one more video today that will be under the fundamental theorem of calculus and being able to do a definite integral. Please stay tuned.